Okay, so now we are gonna record the session. Okay, let's jump into recap. So last week, I noticed there's a lot of new faces here today, so this may not be familiar to you, but last week we touched on the topic of what are structs, which are structures for short, and structs are basically a certain structure that you can contain multiple types, data types. And then what are enums? So enums are like enumerations for short, and they are capable of containing multiple variants of different types. So why do we use enumerations? Is because, like, for example, if you want a function to take in multiple types, right? We can actually pass in an enumeration type. So for example, if we pass in an enumeration person, it could be female or male. And you can see that the female variants and the male variants contains different data types. So the function would be able to detect whether the input that it passed in is a female or male, and then you'll do the logic accordingly. Okay. And then after enumerations, we touched on pattern matching. It is basically, if you guys have touched like Python, it's something like the switch logic, where we are comparing a value against patterns, and we are using this symbol called match, right? So, and then we moved on to generic types, where generic types are capable of handling duplications of concepts. So it makes life easier for you, because, like, for example, sometimes you want to create a function that that is applicable to multiple types, and Rust is quite strict on types. So this is one way where you can actually use generic types to handle, for your function to handle different types. Okay, and then lastly, we went to error handling, where I talked about there are two main types of error handling on Rust. One being the unrecoverable error, and the other being the recoverable error. So I talked about when we use unrecoverable error, it's more for like instances where you don't expect at all, and it may be malicious. So you just quit the program and stop. While for recoverable, it may be like some errors that you may expect. People may be mistyping some stuff, and then you can try to correct from there. You try to guess what they're trying to do, and then you do the function anyways. So these are the two error handling. And now I'll jump straight into what are cargo and crates, right? So crates is basically a library of programs, and we call them crates in Rust, right? And cargo is a package manager which manages the different crates. And yeah, this cargo and crates makes things a lot simpler for you when you create a larger program, because up to now we have just been creating very small one function things. Well, we haven't been using a lot of cargo and crates. But when you realize when you create a bigger project, there's multiple files you need to handle, there's instructions, there's states that you need to handle. So this is where crates come to play. Okay. So for cargo, it introduces two metadata files, and they contain similar data, but the only difference is that for cargo.toml, I'll just say toml or something, it is written by the developer, right? So as a developer, you'll write what are the dependencies, like this is something very, maybe if you're familiar with JavaScript, it's very similar to package.json, where you write down your dependencies, like I don't know, whatever, like, yeah. And then, but then for cargo.toml, you can, I'll show you an example later, next slide, where you can write down a link to the GitHub repository, and then when you do a compile using the Rust-C compiler, it will actually automatically create a cargo.log. So actually very similar also for JavaScript. There's also a .log file being created when you do a compile on it. Okay, so basically cargo and crates really introduces conventions to make things developers' life easier. Okay, so for cargo, so like what I said, it describes the dependencies in a broad sense written by developers, and But for Cargolog, it contains the exact information, so you can expect like the exact sort of like the exact versions down to the exact commit of the GitHub repository. Okay, it's maintained by Cargo, and you don't have to manually edit it as a developer. So this is an example of how a cargo.toml will look like. So you can see that the dependencies here, we are saying that, oh, we need a regex dependency, and we reference it to a GitHub repository link. So when you compile this, it'll give you a cargo.log file, which will say that, oh, this version one for this regex dependency, this is version 1.50, and this is the relevant associated commit. Okay. So now, so what are modules? So modules actually, it very simply said, it helps you organize things better, right? It allows for organization of code for readability, and for example, when other developers try to look at your code, it'll be easier for them to understand. It also helps you control privacy of certain items, but I won't be touching privacy for this session. Yeah, so if you are interested, you can maybe read up on your own on what are like privacy in Rust. So maybe just a brief example overview. Rust items are by default private, so you have to make it public by using the pub keyword. Okay, so modules can also hold definition of other items inside, so you can include other modules, and this allow you to group them. There's also related definitions together. So this is one example of how a module will look like, right? So say maybe you're a restaurant, right? And your first module would be the front of house, the house of the restaurant. And then subsequently, within the restaurant itself, there are different functions. There's one for hosting, like bringing the customers into the restaurant. So you create another module called hosting, while there's one for the waiter or waitress, right, where it's serving the customer. So these are so for hosting, there's like adding to the wait list, sitting into the table, but for serving, there's like taking the order, serving the order, and then taking the payment. So that's how you actually separate the different functions. You organize it. So we'll go next to what is use. So use is actually not an import statement. Okay, it's more of like an alias where you create one or more local name bindings from some other path, right? So it is usually used to shorten the path, so then you don't have to really type so much, and it's typically declared at the top of module, but not necessarily so. So here's one example of how we would use the use. So for example, we have you can see that we have a module called phrases, right? And then underneath the module phrases, there's greetings module, and then there's a function hello within phrases and within greetings. So it's at the most bottom, most nested piece, right? So without using the use, you can see that you have to type out the entire path. So it's phrases, namespace, greetings, namespace, hello, right? Which is quite cumbersome. So what you do is you use phrases, namespace, greetings, and then you create an alias for module. So from then on, at the second example, right, you can actually just use greetings, namespace, hello to call that function. Or you can even alias a module element so this is a typo. It shouldn't be greetings, namespace, hello here. It should just be hello, right? Where you can just access the function straight away. Okay, so let's now jump. Sorry, I'll just pause here. Any questions so far? Okay, good. So I'll just jump straight into the juicy topic now, which is Solana architecture and programming models and accounts, right? So I want to introduce you guys to one term first called chewing glass, right? I think once you enter the Solana ecosystem, you hear a lot of people saying what's chewing glass. So basically, when you are developing on Solana, you are like chewing glass. A lot of people saying that it's chewing glass because Solana is actually relatively difficult compared to other chains like the EVM chains. So there are a couple of reasons why. So firstly, right, Solana, there's no global state. So there's a separation of logic and state, okay? And secondly, when you pass in like instructions, like transactions into the Solana blockchain, right? When you try to make a transaction, there's actually a limited size. I think it's about 1292 kilobyte that you need to adhere to. And then thirdly, for the inputs that you pass into the Solana program, right? It has to be, the inputs cannot be like a string or cannot be like a plain integer. It has to be converted into a series of bytes. So what I mean by series of bytes would be an array, a list of U8 type, so unsigned 8 integers. So yeah, so unsigned 8 integers are like just basically integers from 0 to 255, things, something like that. Yeah. Yeah. So go next to this. Okay. So you hear a lot, these two things a lot on Solana: programs and accounts, right? So what are programs? Basically, programs are the on-chain smart contract. It doesn't store any states, right? It doesn't store any like data. Okay, so there are no global variables involved. It only contains logic. Okay, it only contains logic. So when we refer to program, what we mean is that the program is actually an account that stores all the code of your smart contract. Okay, yeah. As for accounts, right? Okay, so this may be a bit confusing, right? Because accounts are accounts, program is also an account, right? But the difference is that when you deploy your program onto Solana, it will be stored in an account, but that account will be marked executable. So it's like telling the Solana blockchain that, oh, this account stores the program logic. While for normal account that stores data, it won't be executable. So it will tell Solana that, oh, this account stores your data. Okay. So data for programs is stored in accounts. So like your states lah. So you can treat it more of like a buffer, like a memory lah, and it can be thought of like a file in a operating system. Okay, it includes the metadata that tells the runtime who is allowed to access data and how, and it is held in the validator's memory, and you have to pay rent to stay there. So I'll touch a little bit more on rent later on, if I have the chance. If not, I'll try to talk about it again later. But yeah, I think I'll have the chance to speak about it. Okay. So how does an account look like, right? So when you pass in an account into a Solana program, right, it will deserialize it into this format where where we call it an account info, right? You can see that the first, so see the structure. So this structure contains a data called key, right? So what is key? Key is the public key of your account. So for your wallet address, there's like the public key, private key. So this is the public key. And the next I'll call it variable here, is signer. So it's telling the program whether the account signed for that particular transaction. Okay. And how do you sign for that? You need the private key to sign for that. Okay. And also, is writable tells the program whether the program can actually modify the account in terms of the data or in terms of the lamports. So I'll talk about what are lamports. So one in Solana, 1 billion lamport is one soul. So it's like a Bitcoin, like there's one Bitcoin, and then like I don't know how many makes up one Bitcoin. That term. Yeah. So in Solana is lamports. And for lamports, if you want to deduct Solana from a specific account, like from a wallet address, right, you have to sign the transaction, right? But then if you want to add lamports, you want to add SOL, right? It's like crediting you money, giving you money, right? then the person don't need to have your don't need for you to sign, because like who minds receiving money, right? So that this is Lamport. And for data, so this is what I mentioned just now. Data, it stores the sort of like a memory, but in this case it is serialized into a byte series of bytes. So you can see that it's a list of unsigned 8. And for the owner, it is actually the program that owns the account. So this may get a little bit confusing, but we can talk. I'll talk about programs later. But every account needs to be owned by a program. So even for your wallet, for example, your wallet that you created on Solana, right? It is actually owned by the system program. Yeah. So I'll talk a little bit more about it later on. And then you see this next field there is executable. So this is what I mentioned just now. So if you maybe deploy the code into an account, this executable will be true. So it's telling you that it's Solana program. This is a Solana program. And as for RAN epoch, so here comes the RAN epoch part. So what we mean by RAN epoch, right, is that in Solana, account has data, right? Wallet usually has data. I mean, yeah, account. And for you to store the data, it's actually not free. So you need to actually pay a RAN. And what this RAN epoch tells you is that when is the next epoch that you have to pay for RAN. So there's two type of sort of RAN paying scheme that you can subscribe to. First is like pay by per epoch, and second is you put in. The second is an exemption of RAN. So how do you get exempted from RAN? That means like you can put in Solana blockchain for free this account. You have to put in 2 years worth of RAN. Okay. So how do you calculate what is 2 years worth of RAN? It will be dependent on the amount of data you have in the account. So the larger the data, the higher the RAN. And to calculate that RAN, there's actually a function for you to run to tell you, oh, how much this account needs. Then you can put in the Lamports inside the account. So Lamports is so okay. Okay, so that is an account. And then I'll explain what is an instruction and then what's transaction. Okay. So a basic operational unit on Solana is an instruction. Okay, so you are calling maybe a function of a program, right? And an instruction is split into 3 different parts. So firstly, it is the program ID. Yeah, so it's telling the Solana chain that, hey, which program ID stores the entry point that you're trying to access, or that function that you're trying to call, right? So which smart contract. And then we have accounts. So accounts are all the accounts that you want your program to read or write. So for example, maybe I want to transfer Justin money, right? So what we need 2 accounts, my account and his account. My account, I need to debit my Lamports, while his account, I need to add into his Lamport. So I'll pass in 2 accounts, right? And then there's instruction data. So here, instruction data is what we have seen just now. It is bytes of arrays, series of bytes. And yeah, it has to be serialized, which I'll talk about it later on. And transaction is just a list of instructions. So you can actually pack all the multiple instructions together into one transaction and then send it to the chain for it to run the code. But the catch is that it has to be below 1292 kilobyte for this entire transaction. Okay, so typically clients are the one that the clients are, I would say maybe you are using JavaScript or TypeScript. You'll be submitting the transaction, and you also be fetching data via the RPC API. So what I mean by the RPC API is this, right? When you come to the Solana docs, right, you can see that there is a lot of methods in the JSON RPC API. So for example, let's look in get account info, right? And then get account info takes in these parameters and it will return you all these results, right? And how we call them is like, for example, this, right? So we won't be using the code doing this way, but we'll be using an SDK, a TypeScript SDK that will allow you to access the JSON RPC API. But yeah, it's something good for you to know. Okay. Any questions so far? No worries, I can just echo whatever you say. Yeah.
No, basically just right there, just now I mentioned that the rent that you pay for 2 years.
Yeah.
It's going to stay forever, right?
Yeah.
Have to pay.
Yeah.
Pay for that. What if you increase the data that you have to store?
Right. So typically we for accounts, right, we usually set the data and we don't change it. But it is possible to change it, but it's actually quite difficult. Yeah, so it's not recommended to. So usually we will actually maybe provision access data space for you to maybe in the future you wanna do more improvements to the whatever program. Then yeah, but in any case, if you want to increase the data, yes, you need to increase the rent. Yeah, if not, they'll start deducting. Okay. Okay, so let's look into what what the accounts are for each account element in the array where you send into JSON RPC API. So, so the first thing would be the public key, right? The public key of the account that you want to either read or you want to write, right? And then next you'll be the is signer, right? Telling whether you have the rightful owner. Okay, I think I have a question in the chat. Should I answer it now? Okay, so Brian asked, when pushing a contract on Solana, when successful, you produce a program ID. This program ID is different from the account address, right? From my understanding, a contract is also an account. A wallet is also an account. All right, so this one is different from the account. It's actually so the program. So when you create a program on Solana, actually, what happens is when you build it and when you deploy it, they will actually create a key pair for you, where it's which will be the public key of your program ID, and that is the account that will be storing your program's logic. And how do you access the logic after that? It's by passing in the program ID, which is the one that when you deploy, when they create it for you, that public key, that is your program ID. Yeah. So if I understand your question correctly, then they are actually the same. Okay, so unless you're talking about an account address that maybe you are trying to read or write, that will be totally different from program ID. Okay, then let's move on. Yeah, so is signer is writable. So it's writable, just tell you whether the account can be modified or not. So like the data or the lamp ports. So for example, let's look at account 1, right? You see that we passed in account 1 and is signer and is writable is false. This means that when the program tries to do any modification to the account 1, either data or lamp port, this will throw an error, yeah, because it is false. So for account 2, that will work. Okay. No, I don't think there's a private struct account. Accounts are typically public. Yeah. Because I mean you require programs to access them. Okay. We will move on. Okay, so we talked about account, right? And then so we talked about program ID, which is the account that stores the program code. We talked about accounts, which is when you try to call the program function, what are the accounts it needs to read or write. Then we'll pass it instructions. So it's like you can say that it's like an input parameter, right? Where you can see that it's a byte array of a certain size. So it's used for sending input data to on-chain programs. So you can see that, okay, so these are all like a series of U8 integers, right? Actually, this, when you deserialize it, you'll be converted into a string, and the string is actually glass chewer. Okay. So just a high level overview of recap of what I just talked about. For program, if you are a blockchain developer, you'll be coding in either Rust, C, or C++. And these programs, when you it will be loaded up onto a BPF, right? Where it will actually be uploaded into the BPF bytecode on the Solana blockchain, right? This is how you deploy the Rust program. But if you want to tap on the program's methods, right? Calling the program, that is where the client comes in, where you can either use JavaScript SDK, Rust SDK to call that program. So it can either be a transaction or it can be a query. Okay. Any questions so far? Okay, so I'll jump straight into Solana programs. So when you write and compile programs, Solana programs are compiled to this BPF thing called a Berkeley packet filter. So you have to pass it into a BPF loader for it to be that version that it requires, Solana program requires. And programs can be written in any language actually in Solana, but only Rust, as long as it compiles to the BPF bytecode. So right now only Rust, C++, and C are currently supported, but I would say 99% of the blockchain devs on Solana uses Rust. Okay. So how would you structure your say when you try to code a program? How do you start going about it? So this is a typical project layout. It's not enforced, and I actually don't really practice this. I have another style that I prefer more. But yeah, this is something that is very, very typical. So when you see these two slash, right, they are folders. So you can see that there's a source SRC source folder, and within the source folder, there's 6 different files. There's the light.rs, so it's a Rust file also, and it is okay. So for light.rs, it is actually responsible for registering all the modules that's involved in the program. Okay. And then there's an entry point.rs, which contains the entry point of the program. And then there's error.rs, where it contains the program specific errors. And then there's instructions. So instructions are more of like deserializing the instruction data, because if you can recall, we are sending the data over as a byte, as a series of bytes, right? How do we then deserialize it into maybe a string or whatever object that you want it to be? So this is where instruction.rs handles it. And then after you deserialize it, what do you want to do with that input that you have? That's where processor.rs comes in, where the bulk of the program logic, it's in there. And then there's state.rs. So it is mainly for the program objects. So for example, say you have a structure, right? Maybe the structure maybe it's a person. It's the age of the person, it's a number. Maybe it's a U8. Okay, and then there's a name of the person, which is a string. So where are you going to store this object? So this is where you store it. State.rs is where you store all your objects here. Okay, so now that is the custom program that we developers will deploy on Solana, right? That's how we structure our folder here. But there are also native programs, which is like built-in programs deployed to the cluster. So you can think of it like a operating system of a computer. When you buy a computer, there are already default programs that are installed for you, right? So these are like the backbone of the Solana blockchain, and they are part of the validator implementation. So each one has a pre-assigned program ID. So you hear system program a lot, and system program actually has a program ID of just all ones. Okay, so I'll talk more about the native programs. So I'll talk more about the system program here. generally we wouldn't touch much of the config program, stake program, all this, unless you want to do something by like staking to a validator, things like that. You won't really be touching it. Config program will be more of the configs of the blockchain itself, which as a blockchain dev, you won't really be touching it as well. So a little bit more about system program. So by default, when you create an account, all accounts are owned by a system program, right? And what does a system program do? It helps you send transactions. So I mean, send, like for example, if you want to transfer Solana I want to transfer Sol to Justin, system program is actually handling that. I am not handling that. And my wallet, so for example, my wallet address that contains like maybe 100 Sol, if I'm that rich, okay, I will it will be owned by the system program. And how do I send Sol to Justin? Is that I will call the system program. I'll say that, hey, debit my account. I'm a signer. These are my private keys. So I sign it, and then you'll deduct the LAMP ports in my account, and then you'll add the LAMP ports to Justin's account. This is what system program is capable of doing. And only the programs that owns each account has the right to modify it. Okay, only that program. Okay, so interacting with programs, I think I've briefly talked about it already. You use the JSON RPC API to interact with Solana program. So you can, so for JavaScript, right, TypeScript users, you can use the Web3.js library to interact with the API. And this is how you do it. You can look at the client side. And you can only do that after the program is deployed, obviously. Okay, so I'll now talk about serialization and deserialization because it's a very big thing in Solana. And for serialization, what we mean is by we convert an object in memory into a stream of bytes, like the one that you're seeing right now. And then for deserialization, it's just the reverse of it, converting the stream of bytes back to a readable object in memory, right? And it's required because sending data to a program requires it to be serialized in bytes, array of bytes. And obtaining data back from a program, you also obtain it back with a series of bytes. So the deserialization and serialization process is actually very, very important. And because you're not using Anchor, you have to do it manually yourself. But the next few weeks when we introduce Anchor, then this thing will actually be under the hood, right? Where you don't have to manually serialize or deserialize it. All right, so this is how it works. So for example, if let's say I'm the client, I'm on the left-hand side, most of the left-hand side right now. I will start off with an object. And maybe my object contains name, which is a string, age, which is a integer, right? I will have to serialize it to become a stream of bytes, send it to the JSON RPC API, right? And then the program will receive it as a stream of bytes. What the program would do is it will deserialize the stream of bytes into the object name and age, and then you can do its manipulate the code logic from there. So this is what I briefly explained just now, serializing the instruction data sent from a client to Solana. And then after you send it to the Solana program, we first deserialize the instruction data received from the client in the program. And then we also have to deserialize the account info data received from the program, from a client in the program. Okay. And then after you do all the manipulation, maybe your function on the Solana program is a very basic increment age. Whenever the person's birthday passed, you have to increment the age, right? So how it will look like is that the program will take in the account, right? And then what it does is it takes in the account, it's in bytes of arrays, it deserializes it, and then you look at the age of the person, right? And then you access the age, you modify it, you +1. So maybe now, previously 20 years old, now it's 21 years old, but the name stays constant, right? And then the program is in charge of serializing back into bytes of arrays and then storing it back into the account data. Okay. So when we do serialization and deserialization, Bosch is the most common format used for serializing and deserializing Solana. But in fact, you can use any common format you want. But the most important point is that it has to be in sync. So if I use JSON or XML, right, to serialize JSON XML to serialize it, I have to use the same technique to deserialize it on Solana. And the reason why we are using Bosch right now is because it is a strongly supported serialization and deserialization tool that is being developed by this protocol on Solana called Project Serum, right? And they are also the ones behind Anchor. So I'll talk a little bit about that later on. And yeah, so just a little bit more info. Integers are little endian. Sizes of the dynamic containers are written before values as unsigned 32. Okay? Yeah.
Yeah, I was asking if when the serialize the on-chain Solana program uses the serialized bytes.
Yeah.
But for what uses the deserialized bytes? Is it Rust or is it the front end or is it
both actually? So when, for example, when we are talking about name and age, right? For example, if you want to read the person's name in string, it has to be deserialized, right? And maybe if you want to give a name to a person, it has to be in string format. So it has to be converted into a serialized bytes first, sent to the program. The program has to deserialize it. I mean, it doesn't have to be deserialized if, let's say, you're not trying to like read or modify it, right? But let's say if you want to access it, then it has to be deserialized, and then you have to modify, like maybe increase the age +1, and then you serialize it, and then you store it into the account. Yeah. Okay. So I'll just go through very quickly the Bosch example. Okay. So here you can see that this is the client side code. So this is JavaScript. So you can import or the exported modules from Bosch, and it's called Project Serum, owned by Serum Protocol, and it's Bosch. So how do you create an object? So first you do Bosch.struct, and then you create a list of what are the objects that you require, and then let's say I want to create a payload, right? And this is the information I want. The public key is this. The string is class. It's a U8. It's an unsigned 8, 7, right? So I will define the payload here, but notice that the payload right now is not serialized. It's still a JavaScript object. So how do you serialize it? You use params.encode the payload, which is this object here in JavaScript, and then you pass in the buffer as well, which is the space. Okay, that you have. You first allocate a big enough buffer because you don't know the space that you'll be occupying, right? But then after you serialize it already, right, you can actually slice the buffer so that you just use the space that you use is just nice, the data that you need. And this also will save you in rent, right? Because the larger the data, the account host, the more expensive the rent is. Okay, so yeah. No, so if you allocate lesser than the 2 years worth of space, then it will charge the per airport. Yeah. So yeah, anyways, the serializing of data, it is params.encode because you previously defined a Bosch structure, params, that tells you that it contains a uint8, public key, and a string, right? Which you encode it here, the payload, it has the same object structure, and then you also give it a buffer. Okay. So when you send it, it has been serialized, right? Previously you encoded it, serialized, you send it to a transaction. How do you deserialize it? So thank God there's this derived macro where it is called Bosch serialize and Bosch deserialize, right? And you put it right above the structure of your object lah, or more so a structure. In Rust, that's why you call it structure. And what it does is that it helps you implement the associated serialization and deserialization function that you need to deserialize the instruction that comes in. Okay, so I'll explain a bit more about that. Right. So you can see that our structure is called params here. Right. So firstly, on the on-chain program, you use the Solana program from the Bosch crate as well. It's a function called try from slice uncheck. Okay. And then we'll first talk about this, right? Where for params, right? You look at this params, it's a structure, but then it already has a implementation called try from slice, right? So for those who are new to here, right? For us, there's structures where it contains the data, and then there are implementation that are functions that are related to the structure. Okay, so it's like something like an object, right? Because object for data also has its own function. Okay, so what happens is you will call the params function, try from slice, and you put in the data where it will try to conform that instructions that you send in into this structure that you define here. Okay. But if it doesn't conform to it, this will fail, right? So for this may fail sometimes when the instruction you send in is not an exact match to the bytes that they would expect for that structure. Yeah. So if you are trying to send an instruction that has maybe extra space or whatsoever, you have to use this function try from slice uncheck, which tells you that is unchecked. They did not check whether it is exact match. And then yeah, you have to unwrap it. I won't go into details what's unwrap, but if you guys are interested, you can look up what are unwraps. It basically, for example, for this, when you call the params and then you give it data, you sort of return an output where it's a result output where it can either be an error or it can be a okay, right? And then when you unwrap it, you unwrap it to that exact. So it's two options. One is error, one is okay. So what you do when you unwrap it is if it's an error, you throw an error and stop the program. If it's okay, you send the exact data, absolute data of that output. So this is what unwrap does. Okay, so for example, you write everything already, right? You write everything, and then you do all your logic. Like for example, you minus the h, -1 h, or you +1 the h, and then you're done. You want to change the data of the account. What you do is you do a d.serialize, and then you pass in data.borrow mutate, and then yeah. So I will explain slightly a bit more on what this means later if you have time. But yeah, so basically this is just telling Solana that hey, this data that I borrowed is a mutable data of the account. So what I mean by mutable is like it can be modified, and when we serialize it, I want to store it in this borrowed data. Okay, so the account state will change, the account data will change. So once account data change, right? For example, let's say you pass in a person's account, you increment the age +1, right? How do you confirm that the age has really incremented? On the client side, you can actually call the .get account info to get all the data of the account that you have supposedly modified, right? But that data would be a serialized format. So what you have to do is you have to pass in the data. So the data is buffer here, and you have to params.decode the buffer to get that object, original object. Yeah. That is actually all for the theory today. Oh, any questions? How do you guys think about Solana? Is it difficult? Very heavy? Yeah, I mean, you can try to look back at the slides when you all try to do the exercise. I think now it's already quite late already. Yeah, so I don't think I will go through the exercise. Maybe next week, we can go through the exercise. Yeah, and then maybe you guys can maybe take it home and do the exercise. But maybe I just show you how the exercise looks like. It's actually very guided, I would say. There's no really try to ask you to code something of your own, but like basically you just copy and paste and read the instructions of what you're trying what you're pasting yourself, and then you try to understand there. So if you got any questions, feel free to just ask on the group chat. I'm sure like either myself or Justin, or I'm pretty sure there are experienced developers on our group chat that would answer your question. Right. So there are actually comments, inline comments here that you guys can read if you guys don't understand what each lines are doing. Okay, so yeah, any questions from the chat? Just so Brian asked, just to confirm, client serializing, deserializing is the front end side. On-chain serializing and deserializing is in the Rust code. Yes, you're right. For client serializing, deserializing, it is typically on the front end. And for the on-chain, it is typically you write it on the Rust code where you use the Bosch traits, right? And then, but then on Solana, it won't be Rust code. You'll be compiled to a BPF format. Yeah. So that's all. Any more questions before we end today?
You explain the chewing glass.
Oh, the chewing glass. So the founder of his name is Anatoly. So he one day went up on stage and he started saying like, developers on our ecosystem are actually chewing glass. So and then we asked like, why are we chewing glass? So it's actually he just says that Solana is actually freaking hard but for a good reason, right? Because like the way you separate your logic and your state and all these things allows it to be a lot more scalable. And in the future, if you want to tap to potentially billions of users, I think this or he thinks this should be the way forward going forward lah. Yeah. So that's the origination of chewing glass. Okay. That's all.
Yeah, awesome. So thank you very much, Vincent. So right now we are gonna take about 25-minute break. So later on at 8:30, we will have some presentation going on. At the same time, we will also be announcing some of things that we have for you guys. So for example, we have some open source project that we got coming on, as well as some hackathon information that we are planning. So yeah, we'll begin that segment at 8:30. Okay, so for those of you who are online right now, feel free to stay on or come back on Zoom later on. Okay, see you guys.
Awesome, let's go!
Hi, can you guys hear me?
Yeah, loud and clear.
Okay, hi everyone. I'm Mud and
I'm Daniel.
yeah, so we are building SoMove. So just a brief background about ourselves.
Yeah, so basically I'm a computer vision researcher turned indie game developer.
Yeah, then for myself, I did some games back in school, and then I went to the dark side for a bit in finance, and then now I'm kind of coming back to do some games, to build games again. Okay, so I mean, let's just talk why we were planning to like build a game on the metaverse, right? Because I think now you can see like most of the money that is in crypto right now is mostly in DeFi, right? Like you can see everyone wants to build like an FX protocol or some exotics product. But I think especially in Singapore, like a lot of the game developers, or at least the AAA studios like Ubisoft and Bandai and all these people, when we talk to them, they are still quite skeptical about crypto, right? I think there's some bad vibe just in terms of our NFTs and like the scams and all these things that are happening, right? So we want to change that. I think we want to be, as game developers ourselves, we realize the potential of the metaverse, and some of the opportunities that are here right now. Like you can see Binance, Animoca Brands, Spartan, right? Some of these big funds, they have like hundreds of millions of dollars in GameFi funding that you can actually go towards. So I think some of the research that we've done on the current games that are already live. So if you guys have tried some of the Ethereum-based games like Mana, Sand, Splinterlands, Derby Stars, some of these games, they have a lot more focus on yield rather than the gameplay itself. So you can see they'll just have for example, one of the games, they just have like a big plot of land that you can buy, but no one actually goes to your land, and it's like one visitor every month, so there's no point in building those kind of games. So we see that problem, like me, I then see that, and we want to build a game that is actually more fun and engaging for players. So the inspiration for SoMove comes from I think the younger, I mean, I'm not that old, but the younger demographic, you can see that they're all into TikTok and dancing and, sharing with their friends about all the 15-second, 20-second dance. And then it becomes a trend, right? And then it gets spread really fast. And then additionally, some of you guys might have played Pokemon Go, Just Dance, or Beat Saber, right? So these are the inspiration for SoMove. And then based on these games, we see that we try to take some of the good things. For example, Beat Saber, they have like trendy pop music. So people come back because, they can have fun with their friends, but additionally, you get to lose some calories, right? So that's a good thing. And then TikTok, shareable on social media. There's a lot of ways that you can spread your 15-second, 20-second dance to everyone. And then some of the bad things, or not so bad, but not so good things that we see with some of these games is that, for example, for Beat Saber, you have to buy a VR headset, and that already kind of offset you like $500, $700, right? So we want to remove that barrier. We want to just leverage on existing technologies like machine learning models, so that you don't really have to buy any VR headset. You can just use your camera, your phone camera, or your laptop camera, and then you can have fun and play with your friends. So that's where SoMove comes in. It's a mobile AR game. We are focusing more on fitness and dance, and we want it to be as casual as possible. So we just focus purely on one core mechanic, which is motion capture and the dance elements that come with it. So we will do the game demo at the end, and then if you guys have any question later on during the game demo, you can go ahead and ask us. But the progress so far has been on January. Then we're exploring some of these music-based games, and then we pitched and we met at the Hack House SG, where the team got formed, and me and Dan actually decided to build this game together. And then we also submitted to the Retype Hackathon. We didn't win anything, but I think that was like a good milestone to reach. So we have the alpha version launch. So all these links will be in the Discord later if you guys join, and you guys can play it at home. So the current roadmap for the Q2 2022, we already have the Android and the desktop support out, and the alpha gameplay as well. And then we also have the social channels already established, so you guys can join and share your scores with everyone. And then the following months that will come after this, we are onboarding a couple of artists, and also we have a few plans to have our own NFT Genesis launch, so that to set up the universe and set up the setting of how the game will look like. Yeah, and then we have future plans to kind of build our own primary marketplace. Like, of course, it will support secondary marketplace like Magic Eden, some of these other secondary marketplaces. But I think we are trying to we want to contain the liquidity, I guess, in the ecosystem itself, and not rely on secondary marketplaces. And then hopefully by 2023 we'll have the token governance and in-game currency launched on mainnet. Yeah, so that's our rough roadmap right now. Yeah, so we have some advisors that are on board our project. So some of these advisors are industry veterans from gaming schools like DigiPen. We also have UI UX software engineers from Ubisoft as well. And I think particularly why we are looking for this kind of advisors is because a lot of the game right now that are built on crypto, they are built by software engineers that do not have the training in a AAA studio, right? So the thought process, the methodology of approaching of how you want to design and build the game is not as robust as someone who already made Assassin's Creed or some of the bigger games that I'm pretty sure all of you have played. So yeah, we are hiring artists specifically for in-game 2D concept artists and also 3D technical artists that will help with the modeling and the shaders in the Unity engine that we're using. So if you guys know someone or you guys want to contribute and join the team, let us know. Yeah, so this is our contact. This is our Discord channel that you can join, and the Twitter handle as well. Okay, so now we'll just do a demo. I don't know whether, so we'll do the game demo right now.
Yeah.
Yeah. All right. So can you stop sharing and can you see you? Oh yeah, okay. Oh, you stop sharing a video. You can see it? Oh,
Yeah, screen sharing from my
end. Let's go.
Is it okay?
You need a light on. Just
Play?
for me.
Okay, sure. I think your mic will move over here.
Most cardio I had in
I guess the people behind might want to move to a side.
because
Yeah,
they use like a motion, like a model, so they might think that that's my leg, but it's not.
Yeah. Yeah. Oh.
This is a song. Oh yeah.
Maybe I
Turn it down. Yes, sir. Yeah, so that's basically the game. I think if you guys want to try it, just join the Discord and there's a link for let's play at home with your friends. Maybe do some with.
Yeah.
Awesome. Right. Thanks.
you're thinking of picking some question.
Oh yeah, sure. Go ahead. If you have any
Yeah,
questions.
so I got some question. So what is the next step for this project? Gaming version.
Right. I think the main. Stop it. It's gonna restart.
Okay.
I think the main. Let me catch my breath. Yeah, I think the main.
Yeah, repeat the question so that.
Oh. Okay. It's in the chat. I don't see it.
Yeah, no, I say like.
Oh, repeat your question.
My question.
Oh, okay. So I think Justin, he asked what are the next steps for the game. So I think we need more playtesters. So I think the way that the game development works is that you in the alpha stage you wanna bring as much playtesters as possible, so that you want to balance the game better. So as you can see, there are some moments where it's hard for me to reach certain icons, right? So those are the balance that we want to improve for the game. And then the most immediate ones are that playtesting, improving gameplay, and also improving the icons. I think getting an artist to kind of help out with some of the icons would be, yeah. So those are, I think, the step that we take maybe in the next 1 or 2 months, and then just iterating on the game so that we get as much feedback as possible, and just grow the community. Any more questions?
So when it comes to the Solana side, how is this linked to the?
Right. So I think the first part is definitely the NFT part, right? I think with Metaplex and some of these libraries that are out there, it's easier for us to kind of integrate an NFT project with the game. And then in the process, in the pipeline, we also have like NFT music. Like we are talking with a few artists, like local artists, to see if they are willing to kind of make some music for us. And then what's going to happen is that music, you can tokenize it into an NFT, and then through Metaplex you can actually set up a royalty so that some of these musicians can actually get commission and all that. And then additionally, of course, I mean, I'm gonna give a generic answer. Why Solana? It's fast. It's lightweight, right? And also, I think there's a lot of support from VCs right now, so it's definitely a good place to be if you are building a crypto project. Yeah.
So right now, you guys are mainly focusing on the gameplay.
Yes. Yes.
Still quite far from the
Correct.
actual tokenization of things, right?
Yeah. I don't think we want to rush that.
Yeah, that's right.
Right. Yeah, I think some games they rush that part, and then you can see when the token comes in, there's no. I mean, of course, you are learning from other games as well, but then you can see the liquidity dries out and the yields go down, and then the game is not fun to play, so no one actually comes back. So we want to focus on making a good game first, and then like some of these other roadmap or other plans will come in later on. Oh yeah, go ahead. Yeah, we do have plans to do that as well, like occurrence of the icons and all that. So that comes with balancing the game as well. And yeah, we are looking for all the feedback that we can get. So that's a good idea. Like come into Discord and we can talk more about it. Oh, I think this one Dan can explain more because he's the machine learning expert. So.
Oh, so it's just using like pose detection.
Yeah, go ahead.
Yeah.
I think that's a question.
From the.
Oh, you read?
Yes, yeah, based on Unity. Questions.
So so a gentleman here is asking. I think the first question was, can you speed up the game? And then the second question is talking about like the technology that goes behind the motion capture and the detection. Yeah.
Yeah. So like the first one, I think, yeah, we can put it as part of the settings to increase the speed of which the obstacles pop up. And then for the second one, we are built on top of Unity, and then we have integrated Unity with some machine learning models to detect people's poses from their webcam feed.
What's the specs requirement for
Yeah, so you can play on mobile, but the frames are lower, lah. So it's not as sensitive. So sometimes if you like you will miss your body part, lah. Yeah. So like the best experience so far is on desktop still.
So if I play on my phone, it like the machine learning model is deployed in the server or is it in the phone?
It's deployed on your phone. So no personal data is being sent to any server. You just have to find out post detection libraries online. I don't know about that.
Okay. Awesome. Thank you so much for sharing. So yeah, if you drop a link into our chat.
The link tree, right? The link tree, you have it on Discord or something. I'm not sure. Do you have a WhatsApp? I can drop you here.
Just
Sharing,
okay. Sorry.
Suggestions for you.